Okay, so I couldn't avoid putting a picture in anymore. I had to do it, and it literally took me about 10 seconds, so I was just being super lazy. But great, now we can do this problem. So this is just asking you to interpret functions in a different way. It's not graphically, it's not plugging stuff in, it's just from the table. Okay, so the first thing you should do before you even attack this problem is familiarize yourself with this table. Get to know it a little bit before you just jump into a little friendship with it. Okay, so these values are going to be inputs. Those are our x values. That's what I'm seeing based on this table. These values are outputs. These are what we get when we plug x in to f. And these values are also outputs. It's what we get when we plug in x for g. Okay? So for example, f of 1 is 3. G of 3 is negative 2. Okay? So part A. F inverse of g of negative 3. Okay, so the first thing we have to do is we have to find out what g of negative 3 is. Oh, good thing we have a table of inputs here. Okay, so let's go up here. Our inputs, okay, negative 2, 0, 1, 3. Wait, what? Negative 3 is not on here. What is going on? Okay, so maybe I just didn't read the problem carefully enough. Let's see. Let it be given that f of x is an even function and g of x is an odd function. Oh, okay, I see. So g is an odd function, so that means that g of negative 3 we can figure out as long as we know what g of 3 is. Okay, so let's make sure we find that g of 3 is on here. Okay, there it is. Cool. So, by definition of an odd function, g of 3 is going to be equal to negative g of negative 3. Okay, that's what odd functions say. If we plug in the negative of an input, we get the negative of that output. So, if g of 3 was negative 2, then g of negative 3 must be positive 2. Alright, so maybe in this case it's better to say g of negative 3 is actually equal to negative g of 3. Okay, cool. So, we know that g of negative 3 is 2, so now we're going to plug in 2 to the f inverse function. Okay, 2 is going into the f inverse function. So remember what the definition of inverse is. It undoes the original function. So the original function sends an input to an output. The inverse is going to send that output back to the input. Okay, so originally the f function sent our input 0 to 2, so then the inverse is going to send 2 back to 0. So f inverse of 2 is 0, and that is the final answer. Okay, cool. So moving on to number 2 now. We have g inverse of 0 plus 6 times f of 2. So first let's figure out what g inverse of 0 is. So it looks like originally the function g sent negative 2 to 0. So the inverse g is going to send 0 back to negative 2. So g inverse of 0 is going to be equal to negative 2. And then f of 2, then let's figure out what that is. Okay, and 2 is not on here, but f is an even function, which means it's symmetrical. So if negative 2 is equal to 0, then f of 2 should also be equal to 0. So f of 2 is equal to... Oh, see, sorry, I made a mistake here because I didn't familiarize myself with the table as much. X is negative 2, f is 5. Okay, g is 0. We're looking at the f value, though. Okay, so when x is 2, f is going to be 5. All right, great. So now we do g inverse of 0, which we know is negative 2, plus 6 times 5. So we know we have negative 2 plus 30, which equals 28. So we know that g inverse 0 plus 6f of 2 is 28. Okay? Last one, g times f, or g of f inverse of 3. Okay, so we are experts on inverses now. We know that the original function f sent, let's find it, 1 to 3. So the inverse of f is going to send 3 back to 1. So f inverse of 3 is going to be 1. So we're looking for f inverse of 3 is equal to 1. So we're looking for g of 1. And luckily 1 is on here, so we don't have to use the definition of odd. There it is. G of 1 is negative 1. So G of 1 is negative 1, and that is our final answer. Okay, put this as equal to 0. Okay, 0, 28, negative 1, and we're done.